Okay, for today, we're doing combinations. Didn't we do that before? Yes, but we're doing, get ready for this, combinations of combinations. All right, so first of all, a combination looks like this. I have 5 kinds of meat, and I'm going to choose 2 of them. That's an example. Let's just remind you how that works. Everybody write that off to the side, 5C2. Do you get, if you were at Chipotle, for example, and you said, I want chicken and pork in that order? They'd be like, what are you even talking about? The order doesn't matter on a burrito. Okay, so the order doesn't matter on a burrito. So we're using a C. If the order had mattered, we'd be using a P. And then there's this little fraction you're supposed to do with 5 factorial on the top. See if you remember how to do the rest of it. And then check with the kid next to you if you got the same answer at the end. There's something here and there's something here. Simplify it all down, get the answer. I'll pause for a second while you try that one. Well, at least the setup should have been like this. You take this minus this and you put it here. And then you take an extra one of those and you put it there. That's a factorial, got a little strange looking. All right, so then that's 5 times 4 times 3 times 2 times 1 over 3 times 2 times 1 times 2 times 1. That is that at the end there. Easy to forget that. Okay, 3, 2, 1, 3, 2, 1. 20 divided by 2 is 10. Raise your hand if you had 10 for your answer. Awesome. Okay, now when I said combinations of combinations, here's what I meant. We're going to do that times another one. Why would you ever do that? For instance, let's say that you're at Chipotle, and the first thing you have to pick is you have 2 ways to get their product. It can either be in a bowl or it can be in a burrito. There's actually more, but let's just say it's 2. Choose 1. Then you have a choice of what kind of rice do you want. And then it's 2 kinds of rice, and you get to choose. We're going to keep life simple and just say 1, because you could actually pick both, but that's going to get really complicated. And then you have a choice of what kind of like meat or meat-like item. They have a fake meat. I don't know what they, do you know what they call that? They have a name for this. The meat that's not, well, it's not made of meat. It's made of something that's like meat. Tofu? No, it's not tofu. It's got a different name. Nope, that's the meat. That's actually beef. That's
Sofritas?
Sofritas. I think you're right. I think that's it.
It's just on the next slide.
Okay. Oh, it's on the next slide. Okay, so my point, I have 5 of those kinds of things I can put on meats or fake meats. And let's say I can pick, I'm going to change it up here and say instead of picking 1, I'm going to pick 2 of those. Do you get that this is a combination and this is a combination and that's a combination, and I times them all together? Now, here's the really complicated part. Then, if I wanted it to be a probability, I would put it all over all the things that were possible, which is there were 2, 4 plus 5 is 9 ingredients possible. And out of those 9 ingredients, I was going to get 1, 2, 3, 4 of them. These 3 go together and go right here. I call these problems CC over C problems. All right, I know that got complicated, but I'd like you to make sure you get, where did I get the 9 from? You see where I got the 9 from? I'm going to put a box around these. All the possible things I could pick from got added together and went here. And then how many I actually picked? This, and this. That went all added up right there. All right. I'm going to give you another big picture. I just want you to see the big picture here. What's the probability? Go ahead, I understand. What's the probability that you are going to get? Okay, I'm going to deal you 5 cards. I'm going to deal you 5 cards out of a deck. What's the probability you're going to get 4 aces and a king? That would be like the best hand you would just ever get in your life. 4 aces and a king. out of 5 cards. Well, here's how it would go. C, C over C. Just write this down for me. Let me just show you how I would get it. If I'm going to have 5 cards total, that goes here. I have 5. Wait. How many cards are there in a deck? That should be 52, and then the 5 goes here. 52 total cards, and I want 5 of the 52. Does that part make sense so far? Because this is what's possible. This is what all the possible hands. And what I want is 4 aces, and how many of those am I gonna take? All 4. 4, choose 4. And then out of the kings, how many kings are there that you could pick? 4. And you're gonna, I said, get how many? 1. Now there's one last piece that just makes it all balance out. Do you get that there were 52 cards, but the top isn't adding up to the 52 down here? So the last C is all the unchosen cards. There were 44 unchosen cards, and I'm going to choose a 0 of them. Now, actually, I don't even have to have you put that on the top, because do you get if you're going to choose 0 of something, there's only one way to do it. That's equal to 1. But why would you want to put that up there? Because look, that plus that plus that equals 52. And that plus that plus that equals that. Whew. Okay, so it's combinations of combinations. The things that are possible go on the bottom. What you want goes on the top. All right, and that's a probability. You get probabilities, are you always dividing something and you're getting a decimal? So that's why we had to put in a denominator. If all I asked was how many different ways you could be dealt, 4 aces and a king, we could have just done this part. That's how many ways it could happen. When you divide it by something, that turns it into a probability. All right, I thought I would hit you with the big picture first. Now, do you get that combinations are different than permutations? Because the order matters. And by the way, if it's ever a competition, that's usually how we tell you that the order matters. You know, like first place, second place, third place. Those are clearly the order matters. Nobody wants second place. You'd rather be first place because the prize is usually bigger and it's more impressive and all that stuff. All right. So, here's my Chipotle example. How many different burritos could they make with 3 different toppings? Now, this is the very first question. This is not a CC over C because it's not a probability. And they just want you to lump this all into one thing where you had 3 choices. So just all as once, you would say, well, how many different things could I pick from? And I'm going to put it there. And how many do I get to have? And I'm going to put it there. So let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. And I bet you in the real life there's probably more. But we've got 18 listed. And it does say the other part. It says 3 different toppings. So it's 18C3. Now, I showed you the more advanced way to do it, which is to break them up into like, how many choices of rice do I have? And that's a separate C. How many choices of beans do I have? That's a separate C. But if you put them all together, it is a little simpler, and that's what they start with. But I already showed you the hard ones. So here's an example of one of the harder ones. Would you please set up the C and the C and the C, something, something, something. Set up the three C's. There's no probability here, so we don't have to divide by anything. What's that first C about? Rice.
You need more C's than that.
Dang, you're right. I thought I was reading it different. You're right. I need more C's than this. This is rice. This is beans. This is meat. This is other. And this is salsa. All right. I don't like the question anymore because they made it really complicated in the wording. But I'm going to just start it. With rice, I had two kinds, and I get to pick one. And again, if you're going to get really picky, you can actually have half and half. Or, since rice is free, you can have as much as you want. You can have 2 and 2, double the amount. It would be really confusing if we did this perfect. Beans, you got 2 choices of beans. You get to pick one. Meat, I can look at the meats. That's 1, 2, 3, 4, 5, 6 they list. Anybody know what I actually do know this answer, but I'm curious, do you guys know what chorizo is? Okay, chorizo. I know what it is. I may not know how to pronounce it. Do you know what it is?
I think so.
It's basically like a sausage. It's a kind of spicy sausage. Okay. Anyway, so there were 6 choices of meat, they said. And how many do you get to pick? It doesn't say. Oh, wait. 1 type of. Choose 1. The other things. 3 other toppings. 3. Choose 1 of those. And 2 salsas. Ooh, 2 salsas. They want you to pick 2 kinds of salsa. Some people do that. They mix them. So then how many salsas are there? 1, 2, 3, 4 salsas, and you get to pick 2 of them. I told you, this problem all of a sudden got too complicated. Question or comment? Yes?
I think you did the toppings wrong.
You think so? Okay, so tell me what part you think I messed up.
I think it's like saying you picked 3 of the 4 toppings. Instead of you pick one.
Here's how I read this. It says 1 type of, and then they say rice, beans, and meat. To me, that means you're supposed to pick 1 rice, 1 bean, and 1 meat. Do you agree with that part?
Yeah.
Okay. Do you agree that there's 2 kinds of rice? And I pick 1. 2 kinds of beans, and I pick 1. 6 kinds of meat, and I pick 1. Are you with me so far? Okay, good. Is it the 3, this part, the other?
Yeah.
Okay, so then it says 3 other toppings. Oh, I kind of assumed there were 3 other toppings I could pick 1 of. All right. I still think it's 1 type of the 3 other toppings, but the other toppings are guac, lettuce, sour cream, and cheese. I see what you're saying. So if we go with there's 4 things to pick from there, and if you construed the question as saying you get to pick 3 out of the 4, then I see what you're saying. You would have put like that, wouldn't you? Is that what you're saying?
Yeah.
Okay. I actually agree that that's probably a better way to read it. But you remember me saying I'd like to pull out of this question because they didn't word it really well? It's hard to tell what they meant. But I now think your way of reading it is better than mine. Do you agree with the salsas part at the end?
Yeah.
Okay, good. So this was questionable. All right, let's go on. And this one, there will be only one way that's right on this, and I believe that the wording is good enough that you can do it. And it's going to be a C kind of question. There could be more C's. But it's not a probability, so you don't have to divide by anything. See if you can set this one up. This word is 2.
It's a possibility.
It's how many ways. It's not a probability. Okay. It does seem like there should be a 35 in here somewhere. Would you agree with that? Okay. And usually the biggest number goes here.
No.
Just hold on. Usually the biggest number goes there. You don't, now what's the no about? Do you think the 35 is not going to go there? Or do you think that there's a bigger number that goes there or what?
Smaller number.
Okay. So there were 35 people in attendance this year, including this year's committee. So that means we don't like add any more to be in the committee. So no, maybe you're going to be right in a minute, but so far I think that's how I would start so far. All right, a group of 3 is chosen to plan next year's celebration. So let's just see, could that possibly be it? I'm choosing 3 out of the 35 people. Well, that would be if all of the people are possible. So now I see what you're talking about, because you read further into the problem than I did. How many ways can next year's committee be chosen from those present if, this is the key part, if a person cannot serve 2 years in a row, then do you get there really aren't 35 people to pick from? Because some of these people served last year. So now I'm agreeing with you. At the end of the problem, I'd have to change that to well, there must have been 3 people last year, right? So then it can't be 32 or 35. It's got to be 32 people to pick from. Do you understand that? Does that make sense to you? All right. That was tricky. Okay. The next one. A bag of cookies contains 6 chocolate chip, 5 peanut butter, and 1 oatmeal. Brandon selects 2 cookies at random. Find the probability. Remember that CC over C thing? Probability that Brandon selected 2 chocolate chip cookies. Don't even do this part yet. Just focus on that part of the question. What's the probability he got 2 chocolate chips? Remember, CC over C. And sometimes there's 3 C's on top. See if you can set up the CC over C. I'm going to pause for a second and try to set it up. And don't even get the answer. Just set it up and then compare the setup with the kid next to you. See if you guys agree what should be where. 1 C is for chocolate chip. 1 C is for peanut butter, etc. Okay, so the chocolate chip cookies, they get their own C. So for chocolate chip, I'm going to call that the CC. C. Whew, this gets so confusing. All right, and for chocolate chips, I got 6 chocolate chips, so I got 6 of them. How many do I want to get? Well, what I want, remember that goes on top, is for Brandon to get 2 of those. 6 choose 2. Times the other kind of cookies, there's 5 peanut butter, PB, they get their own C, and there were 5 of them, and how many do I want him to get?
No,
0. Times there were 1 oatmeal cookie, 1 C, and I don't want him to get any of those either. How many of you set up the top correctly? Okay, good. Now, did you have to have that last piece? Technically, you didn't have to technically have either of these, but it would be smart because then you could go this plus that adds up to 12, and that plus that adds up to 2. 12C2. So that's what you divide by.
Yeah.
You guys get it? How many actually got it without me? Nice. I'm impressed. All right, now try this one, the second part. And actually this time, would you please get the decimals for it and divide them and get the final answer? Because that's how it's going to be on the test. This is like the work, and the actual answer is a decimal. So try to get your CC over C and actually divide it and actually get your final decimal. I'll pause for a second while you try this one. Okay, so I've heard some spirited debates on how this should go. I'll tell you what I think. So chocolate chips. Would you agree there were 6 chocolate chips, but he wants 1. 6, 1. What you want goes on top. All the things that were possible will get added up and put on the bottom. All right, next is peanut butters, and he wants to get 1 peanut butter. So how many were there? There were 5 possible. Choose 1. And the oatmeal, because you're going to choose 0 of them, you wouldn't even have to put it there, but it would be smart because then you can make it all add up right. There was 1 oatmeal cookie, and you chose 0 of them. So I know some people just left that off, but then that might mess up your denominator. Your denominator is there were 12 cookies. If you thought there were 11, you forgot the oatmeal one. There were 12. See this plus that. That's why it's smart to include that one. Those add up to 12. Then there's 1 plus 1 plus 0, which adds up to 2. 12 total cookies. He gets 2 of them. Now it's just down to getting decimals for it. And how many of you got the same thing as the kid next to you and you had it set up like this? Nobody had it set up like this, or nobody got the same thing? Or James, what did you get?
For like the answer?
Yeah, final answer.
0.4505 if you doing that, so.
Can anybody verify they got the same exact thing? All right, that's almost everybody. We can assume that is correct. If you didn't, you're like, well, how am I doing it wrong? Get a decimal for this. Get a decimal for these two. And then just very carefully multiply the 2 decimals on the top. Get the answer. And then divide by that. All right. Oh, I think you get the idea on the CC over C. I'm going to skip the cards questions because we have to provide you with a whole chart if you're going to do card questions. Because I get a lot of you don't know what's in a deck of cards. So we're going to go on to marbles. Everybody understands marbles. Would you please just set up the top part, which is not a probability. It's just a CCC kind of question. And then the bottom one, also not a probability. It's just a CCC kind of question. There's a C for the greens, etc. Albright, would you do the first one? Green ones, how many are there? How many do you want?
5. Or 5 green.
And do you want to get all 5, or am I doing this wrong?
No.
Okay, so should we just make up a number of greens he's gonna get, or?
No.
All right, so then we have to do this a different way. If they're not telling me how many greens I'm gonna get, how many orange I'm gonna get, how many blue I'm gonna get, then I gotta put them all together. 5, 6, 7, 8, 9, 10, 11, 12. There's 12 possible, and I'm going to choose 6. That's it. You can't guess how many green and how many orange and how many blue. You'd just be making stuff up. That all gets combined into one. Who had 12C6 there already? Nice job. I misled you, but you've persevered. All right, how about this one? This one is specific. And if it says you're going to get 4 green and 2 blue, that means you know for sure that you don't get any of the other ones. If they didn't say how many, then that means you didn't get any. So here's my green. Here's my blue. There's 5 greens, and I want to get 4. And for the blues, there's 4 blues, and I want to get 2 of them. Raise your hand if you had that one right. Awesome. Now, what if they wanted a probability? Then you divide by what was possible. If they had said a probability, you divide by another C, and it would have been like all of these added up. But remember, there's a total of 5, 6, 7, 8, 9, 10, 11, 12 marbles. It says so at the beginning. So you might want to include that last, like the other kind that we didn't even deal with, which was orange. OJ, good shortcut for that. Anyway, this is not a probability. I'm just telling you, you would do that if it was. I feel like we should get to the homework, and there it is. The last question is turn to the homework. So let's open up the homework. I'll cut a bunch out because I believe in small assignments. Small but daily.
Do you do it to like 2 whatever to every single question? It's not just 2, it's like that's a smaller number. She did a bigger number, factorial, over.
Since it's
small
about
number,
cards under four, we're gonna
times
throw
bigger
that
number.
mouse. Because there isn't a list A
Just
and
look
B. Is
at
there a
it.
list that you saw anywhere
It's
about
like
how much is
it's
possible? I
hard
mean,
to
like how many you want to grab?
Okay, we're just gonna keep it simple and skip number 4 and all of its parts.
Just the one that's on the bottom.
Could you be asked a card question? Yes, on the test you could. But we'd have to provide you with a chart that shows that what everything in the deck is. So there isn't any advantage for kids that play cards. Okay, so 1, 2, and 3. And wait, did I say to skip 4?
Yes.
And it was 4 the last one?
Yeah.
Okay, good. It's just 2 problems, 1, 2, and 3. That's all I got for you for today.